Let's go ahead and let's get started. Let's share up the slides. We're going to be talking about egress traffic analysis at this point. So the point of looking at egress traffic analysis, and the reason why it's something that's so core to anything related to information security and getting started with computer security, is because it's one of the areas that is predominantly ignored in the overall space of computer security today. Why? Well, there's a number of reasons why. One of the main reasons why it tends to be ignored is because it's hard. Let's take a few seconds and let's kind of jot down on a notepad and just think about it. Why do you think it's so incredibly difficult to do egress traffic analysis? Let's look a little bit at how traditional intrusion detection and intrusion prevention works. In previous sessions, we discussed the concept of counting blue cars, right? We're going to sit at an intersection, we're going to find blue cars. And when we detect blue cars, we're going to generate an alert. If we're trying to do signature-based detection, utilizing that type of technique, one of the main things that we run into is the amount of traffic going out, right? That's a good answer. The other thing that we're looking at is bouncing off CDNs, right? But if I'm trying to capture and look at those blue cars, and I'm trying to find very specific signatures, one of the biggest issues that I'm going to run into is encryption. A lot of attackers are using that encryption continuously for the purposes of trying to hide. But your standard users are also using encryption for the purposes of just trying to protect themselves. The same thing with the organizations that we're dealing with. So how can we do egress traffic analysis in such a way so that we can do analysis, still detect malicious attackers, but also be able to honor the concepts of integrity, availability, and the secrecy of the data that's in an environment? So let's go ahead and let's get started. All right. So when we're looking at MITRE, there's a number of different categories that exist in the MITRE attack technique framework that are geared towards looking at egress traffic analysis. This would be in the areas of command and control. So with command and control, we're looking at that C2 traffic that we generated in the earlier session with our app locker lab, where all the traffic is going to port 4444, or the attackers would use something like 443 TLS SSL traffic. And to be honest, a lot of the malware that's out there today can actually do that full TLS SSL to blend in with that environment. If we look at connection and bouncing through a proxy like a CDN, if we're trying to do different cryptographic protocols, we've seen malware using weird protocols like quick protocols or SCTP protocols to try to use a different protocol using multi-honed endpoint systems to make it more difficult to detect that command and control that is actually in your environment. So we still need to be able to detect that type of command and control. We need to be effective in detecting that command and control in our environment as well. So we need that visibility because that basic signature-based alerting is not enough for many organizations to be successful in detecting evil command and control, because that command and control will bounce off of normal things like, let's just say CDNs. Let's say Twitter traffic. Let's say traffic that's going outbound to Gmail, maybe Salesforce. All of these different things can be utilized as evil command and control, and it can be encrypted. So how do we differentiate what is the real traffic and what is the potentially malicious traffic in those connection profiles? For that, we need context. And context comes from understanding the traditional patterns of behavior with a normal user interacting with those services versus an automated piece of malware interacting with those services as well. Also, when we're looking at this egress traffic analysis, we're truly trying to identify gaps in endpoint coverage. We're trying to say the endpoint is catching A, B, and C, but you're going to have devices in your environment that don't have that endpoint protection built in, and you need to have something to catch those gaps. And that would be your network traffic, egress traffic analysis as well. This would be like your Internet of Things, your shadow IT access. And when things go bad, you need to have another source of truth to be able to get the answers, especially for those systems that are not being monitored properly as well. So you're going to be correlating a lot of that host-based analysis from EDRs, which we have a lab and we have a series of sections. We'll be talking about that later, and how that correlates back up to the network traffic that we're seeing as well. And this is one of those few areas where even Gartner and I agree with each other. There needs to be a mix of endpoint detection and that network detection to be able to detect what is truly happening in an environment. So what are the tools at our disposal? Well, one of the main tools we have at our disposal would be NetFlow. This is a standard that was created by Cisco, right? And as you know, when Cisco creates something, many times that standard that Cisco created becomes the de facto standard for the industry. So this is a collection of traffic statistics. We actually have a lab where you can look at like ASA network traffic logs. You can also look at NetFlow version 9 logs and get some information about the traffic that's happening on your environments if you're running a Cisco device. And usually it involves an exporter that would be a system that would export logs. This would be your switch, this would be your edge router, this would be any number of devices that can capture that NetFlow data. And then it would send it to a system that's receiving that data. That would be an importer. That would be like your SIM as a receiver. And then an analysis engine to analyze, which also would be your SIM looking for anomalies in that as well. So this is great, wonderful. Cisco created it as a standard, but one of the problems you ran into very quickly is as soon as Cisco created a standard, immediately everyone was like, we're not going to follow the Cisco standard, and a bunch of other vendors created their own standard. So you have like JFlow, SFlow, a whole bunch of different flows from a whole bunch of other different vendors to create their different implementations of those standards. And it also kind of goes back to that XKCD comic where there's 14 competing standards and someone says, we need to create a new standard that ties them all together. And very quickly, we're now in a situation where we have 15 competing standards. So absolutely, that is problematic. Right? That is absolutely something that we want to be careful of in the industry, but it's never going to stop because it can't stop the signal, Mal. You're going to end up in a situation continuously where vendors want to create new standards for the purposes of trying to create vendor lock-in around their product. And this is nothing new. Before we actually had Unix, if you learned Cray or if you learned VAX or if you learned a number of other different standards, the operating system, the computer system, and the coding language were all intertwined. And they wanted people to be locked into that standard. When Unix came out, one of the most powerful things that Unix provided was an open source operating system, creating C and eventually C++, created an open source standard for an operating system and an open source standard for coding that allowed lots and lots and lots of people to develop on top of it without it being tied into a specific vendor. So what do we have for that? For that, we have Zeek. Zeek is a standard that's not necessarily tied to a specific vendor, even though it is very much funded by Corelight, sorry. By Corelight, they provide appliances, but those appliances under the hood are running the same version of Zeek that you can run. Open source. Now, it's very, very, very fast. The largest customer that we have at Black Hills Information Security and in Active Countermeasures is running 100 gigabits per second. And they're capturing that data from Zeek. Has a huge support base. Tons and tons of people are using Zeek. Has really solid consistency in the way that it handles timestamps. And those timestamps are absolutely essential. And the reason why is many devices handle timestamps differently. For example, do you log a session? Do you log a session at the first SYN packet? Do you log it at the FIN packet at the end? Do you just take somewhere in between the middle and then log those? Different vendors handle that differently. With Zeek, it's handling it extremely consistently on that first SYN packet that came through. Also, it generates separate log files that are metadata of the full packet capture. So you'll have a DNS log, a connection log, an SSL TLS connection log as well. You have all of these different logs of all of the different attributes of the full packet capture so you can quickly get answers to the information that you're actually looking for. Now, This kind of shows how we can start moving away from signature-based detection. We can start looking at the TLS SSL logs. We can start looking at the connection logs. We can start looking at the various logs that services like Zeek provide and try to fingerprint what non-human, potentially malicious traffic actually looks like. And the reason for this is there's right now far too many ways to obfuscate, utilizing things like TLS, SSL, different types of encryption, different types of encoding, and also using third-party services. So when we're talking about network threat hunting or hunt teaming, this means that we're actively looking for advanced attackers. Just play a mental game because I think that this is important. If you're thinking about attackers, I want you to think about Russians. I want you to think about the Chinese. I want you to think about Israelis, the French, UK, even the United States and the NSA. And do you think that those nation state level adversaries have the capability to bypass traditional security technologies? Things like your traditional antivirus, things like your traditional firewall signatures as well. Absolutely, right? Many people would say that that is not even a question. Absolutely, they have that capability. So if you're worried about that level of adversary, which everybody should be, this means that we use those technologies and they're very, very, very important to us. But we also need to be in a position to where we're actively trying to detect the attackers who may be bypassing the security technologies that exist in our organizations. Because if companies like Black Hills Information Security have the ability to bypass AV, IDS, IPS, the attackers do as well. So it requires us to get these logs, start doing analysis of those logs, and then we're going to be throwing some math at this as well. Now we have some really great classes that are available, pay what you can. Active Countermeasures has hunt teaming training. If you just do a search for Active Countermeasures, Chris Brenton, free training, you can see all the different classes that we provide. And we really walk through in great depth how you can do that level of detection. So if you're looking for more pay what you can training options, check out what we have at Active Countermeasures. So speaking of active countermeasures, we released a tool called RITA, Real Intelligence Threat Analytics. Now, what this tool does is it takes those Zeek logs, which are kind of an industry standard that isn't tied to one specific vendor and locked in, and it finds patterns within the network traffic. Specifically, it looks for beacons. It also does deny list checking, DNS views, checks for long connections, and all of it is for free. You can download it right now at the GitHub repository that is up on the slide at this moment. And we're going to get our hands dirty working with Active Countermeasures AC Hunter, and we're also going to be looking at RITA as well. So what does it do and how does it actually work? Now, I could magically wave my hands and say it's all machine learning and AI. And that would come across as really, really, really super weird and almost disingenuous, right? So instead of doing that, I'm going to tell you like how the algorithms work so that you understand whenever I say machine learning, that you understand how that machine learning works and exactly what the algorithms are that we're working with. So I want you to start by kind of thinking of Plato. Right? I know that that sounds weird. We're going to go to Greek philosophers, but Plato was actually a computer scientist. Plato had this idea of the forms, and he was completely hung up on how do we know as human beings that a chair is a chair, that a stool is a stool, that a glass is a glass or a cup, right? How do we know these things? And he was looking at trying to understand how the human mind understands things. And he came up with an analogy of the cave, where we're all sitting at the cave and we're watching shadows, and those shadows are reflections of a perfect form. So he would talk about a chair, and somewhere in the universe, there is a perfect chair, and we're seeing merely shadows of that perfect chair. Turns out that's pretty darn close to computer science. All right, so let's take the concept of a chair. Let's take a few moments and let's just kind of think through and maybe jot down or type in, what are the characteristics of a chair? If we're looking at a chair, what is the chairness attribute of a chair? Kind of typing some things in, thinking about it, all right? So if we're looking at a chair, right, I want you to think of what chairness is, but what are all the characteristics? You could say it has 4 legs. Some chairs have three, right? It has some place that you can sit. That's very good. Some chairs have a back. Is a log a chair or is a log just a seat, right? So let's not share the Discord. By the way, let's keep it on the slides because there we go. Thank you. So if we're thinking of chairness, there's multiple attributes of a chair. And it turns out that there's absolutely no correct answer for what a chair is, but there's different attributes for chairness. And you can weight those attributes of chairness differently. So you can say if it has a back and you can sit on it, that's a really strong indicator. If it has four legs, that may be a good indicator, but it's not the most important indicator. It's going to be a contributing indicator of chairness. So as a human being, when you look at something, the more attributes that a chair actually has, the more likely that we as human beings are going to call that thing a chair. So now let's look at that from the purposes of beacon detection in an environment. What are some of the attributes of a beacon? So I have three different attributes of the beacon here, just three of them. We have interval, data size, and we also have connection time. All right. So I'm going to go through each of these attributes of a beacon. And it turns out there's actually more attributes of a beacon, but I just want to talk about these three because it kind of looks like a flux capacitor. And I think that that's pretty darn cool, right? So we have the interval. All right, so we're going to use an analogy to understand a beacon. How many of you that are watching this right now have children or have been around small children, right? So how many people have encountered these scary creatures called children? Don't even get me started on teenagers. They're even more scary, but you have children that are out there, right? And inevitably, if you spend any time around a child, you're going to hear a conversation that goes like this. Mom, 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 dad, 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 dad. That is a beacon. In fact, that's a really good representation of a perfect beacon. The interval is really consistent, right? You have mom, 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 mom. We have that very consistent heartbeat. We have the data size, DAD, 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 or MOM, MOM, MOM. It's the exact same data size. The connection time, well, there's very little connection time. It takes less than a second for them to get those words out. So we have a really strong connection and interval and data size and connection time. So what we do is we try to identify clusters of consistency in interval and in data size and in con time. All right, interval, data size, and con time. Now, there's a number of algorithms that can be used to identify these consistencies. You can be using MADMOM, medium average distribution to the mean. You could also use k-means clustering, which a lot of products use, and I'm going to talk more about that here a little bit later, but we can use k-means clustering as a way to identify clusters. Because even though the child is going mom, 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 dad, 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 and it hears like it's super, super, super consistent, it's actually not. There is a little bit of variance, but they're really close to each other, okay? They're really, really, really close to each other. So we're looking for those clusters. So the more those clusters move towards the middle of our flux capacitor, the closer it gets to a perfect interval, perfect data size, perfect connection time, and that gets us to a perfect value of 1. And notice a lot of these approach, but they don't actually get to 1, and that's okay. Because when you're using MADMOM or k-means clustering, it can identify these connection attributes to develop the chairness or the beaconiness, whatever, of the connection intervals for potential C2 traffic. So we can also look at long connections, right? So for a long connection, I want you to think of a child who maybe is a little bit smarter, right? And I know this is kind of a charged thing, but I'm just going to bring this up. Have you ever been around somebody that refers to their children as geniuses? Think about this, right? You'll be around someone and they're like, well, my little Billy, my little Susie, they're just a little genius. They're just doing so good in school. They do good in gymnastics. They do good in basketball. They're getting great grades. The future's so bright. They got to wear shades, right? And that's awesome. That child is clearly bright and is destined to do great things. But that child is probably not a genius, right? And that's okay. You really don't want your kids to be geniuses. Trust me. Do some research on this, and you'll find out the people that are like true geniuses have some other issues that come along with that quite often. They're not all like Goodwill Hunting, where, yeah, it's a strapping young lad who's fun to talk to and fun to be around who's prone to violent outbursts from time to time. But instead of that beaconing, where it's like, mom, 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 they'll be like, mom, 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 right? Like they're doing it in a different way, and it makes it harder to ignore. So to detect that type of beacon, we can still detect it. So I want you to imagine 24 hours is represented by a string of hard spaghetti, mom spaghetti, because there's vomit already on a sweater already, right? So we have this string of spaghetti. And if I break that string of spaghetti, it is very unlikely that I'm going to break that string of spaghetti in a very consistent way. It's going to break in some long pieces, some tiny pieces, some medium pieces, some itty bitty little teeny tiny pieces, right? So if you're dealing with a genius level backdoor, they're not going to come in with a very strong connection profile that's like a beacon, like I just did. It's not going to be like that. So it's going to be randomized in its connection profiles. But if we take those connections and we assemble them end to end, you're going to see that the two systems are in constant communication with each other, because we reassemble those spaghetti pieces and we can see that those spaghetti pieces are all connected, and it's a 24-hour duration between those two systems talking to each other. So when we're looking at beacons, and this is raw output from RITA, and it's running it through the mathematics that it uses to detect it, you can see that we have these top two connections that have a perfect beacon. On the left-hand side, the way it comes out from the database is we've got the connection profile of 1. That means it is a perfect beacon. But the big thing is we have the internal and the external IP address. Look at the number of connections there. The top one, we have 108,000 connections. And the next one down, we have 20,054 connections. And they're all perfect. That means we can say with a high level of confidence, this is not a human being. This is automated, and there's a lot of traffic matching that connection profile. Now, this gets into something that's kind of controversial with RITA and AC Hunter. And just stick with me for a couple of moments, because I know it sounds like absolute garbage. Just stick with me. There are no false positives with RITA. If RITA says it has a value of 1, it is absolutely an automated beacon in your environment. That does not mean that it is malicious necessarily. It just means it's a non-human beacon that is leaving your environment. Once again, it doesn't mean it's malicious. It just means it's something that probably needs to be investigated. And by the way, AC Hunter and RITA have the capability to incorporate allow listing. So if it was connecting out to an IP address and it's Google Update, it's Microsoft updates, beaconing on a regular basis, it's probably already allow listed, but you can allow list it as well. All right, so pretty cool. So what are you going to find in your environment? There's going to be a bunch of things that you're going to discover. And it's not all going to be malware. It isn't, but it may be security relevant. So we have some examples up here. In the top left-hand corner, TeamViewer was compromised back in 2016. And you can also look at other breaches and other RMM tools, right? And a user in your environment may use protocols and services like TeamViewer and LogMeIn so that they can gain access to their home computer to bypass your porn controls, or they can bypass your anti-gambling controls by accessing their home computer via TeamViewer. Now, that doesn't necessarily mean it's malware. No. But don't you want to be aware of your users in your environment that are using TeamViewer to bypass the controls that you have? Absolutely, right? Then one in the upper right-hand corner. This is an RDP server. Remote desktop protocol is something that's used consistently by a wide variety of different people. But you got to know which ones are exposed directly to the internet, or which of your users are using RDP to get out of your environment, once again, to bypass security controls. You can detect that with AC Hunter and with RITA. The lower left-hand corner, we saw this in a medical organization a number of years ago where they shut down wireless because that's just smart in a hospital. And some of the devices didn't have like capability for Ethernet cables. So they went and they bought USB to Ethernet dongles The problem with all of these dongles is all of them communicated back to the manufacturer, and that little dongle has an embedded Linux kernel that you can remotely manage all of your dongles. If this sounds like a land turtle from Hack5, that's because it's pretty much exactly under the hood, the same thing as a land turtle. And yes, you can absolutely detect that as well. Some other things you might want to look at would be like the oh my god cable from Hack5 shops. And in the lower right hand, Nuance, if you remember Dragon Naturally Speaking software, where you can talk to your computer and it would transcribe what you're saying, Nuance for remote troubleshooting issues had the capability of enabling remote management of that computer to help people troubleshoot issues. Once again, this may not be a security issue, but is it something your security team wants to be aware of? Absolutely. We all should be aware of that as well. And all of this is free. What's under the hood in all of these different things is a tool called RITA, Real Intelligence Threat Analytics. And RITA, as it stands right now, is in fact a free tool. And it is named after my mother. By the way, I didn't name RITA, the development team did. And the reason why is my mom did a lot of finance stuff with Black Hills Information Security, got to know a lot of the developers really, really, really well. And she kind of became a mom for the developers. And they decided to name it after her. And also, my mom was featured in an episode of Darknet Diaries. I think it was number 67, The Big House. So you should go check out that one. But my mom broke into a prison pretending to be a health inspector. And I talk about that story and what she did. So check that out. It was pretty cool. But my mom passed away a number of years ago from cancer. And I'm getting to the point where I can talk about this without crying. So that's a good thing. Or maybe it's not a good thing. I don't know. But one of the things when we were going down to Cancer Treatment Centers of America, my dad was really just there. And a couple of times I went down and helped. And I remember sitting out in the hallway, we were releasing this tool, and she had just gotten done with chemo. And she was sleeping in the bedroom, and I was out in the hall, and she woke up and she came out and she sat down next to me, and she got a chance to talk to like 1,200 people that were on a webcast and talk about what she was going through and what she was doing. And one of the things she asked is like, keep this tool for free because the community has been so good to us in Black Hills Information Security. So this tool is free, and it will continue to be free because we've gotten a whole bunch of patents on what this tool actually does. So anybody can use it. They just have to give credit to the project, not that a lot of vendors do. But it is free, and we're releasing it to the public for free as well. So if we want to get that data and we want to get that analysis, we have a number of different things we can do, right? We can do full packet capture. So when you hear PCAP, that's what it means, packet capture, right? If you do a full packet capture, it's incredibly portable. Tools like Wireshark and TCP dump have the capability to do full packet capture off of a switch that's running on a span or a mirrored port. So you can see all of that traffic. And then Zeek would take that, parse it, break it down into much smaller data, like metadata logs, so that you can then import it into a tool like RITA and AC Hunter for analysis as well. Also, when we're playing with this, we want to make sure that our Zeek and RITA system is set up pre-network address translation. So let me explain network address translation. So when you have 1,000 computers in an environment, or 10,000, they go to your edge firewall, and all of those systems will appear to come from that firewall. So we want to be on the inside of that firewall so we can see the internal IP addresses. We call this the internal RFC 1918 IP addresses. Those are the non-publicly routable IP addresses. That'd be like 192.168, 10, 172.16 addresses that you would see as RFC 1918. But we want to be able to see those internal systems so we can differentiate which IP in the environment is making those beacons coming out of that environment as well. So you can do this in a number of different ways. In a small environment, you can actually run Zeek on a small Raspberry Pi. 1 to 2 gigabits on a Raspberry Pi pretty easily. But on larger environments, you're going to want to look at like a Gigamon or a Corelight. And the reason why is these products are very plug and play. You set them up in the environment, you set them in line, and then you can sidechain and you can fork off full packet capture to a number of different ports, to a number of different IDS, IPS, Zeek sensors, things like that in your environment. Now, these are expensive. I want to make that clear. But you also have got to ask, what is your time worth? Right? If you're looking at something, it's like we can do it for free, but it takes an analyst 2 months to get it up and running properly, getting it tuned properly. You may just want to buy the device. It may just be worth eating that cost. Also, the time associated with it, you also have the capability to say, I need this now in our environment to be able to do threat hunting or working an incident versus a number of weeks or a number of months to get the proper devices in. The other thing that you can do, and we have a lab with this, and I'll show you that here in a couple of seconds when we get to the lab, is you can use a firewall, which is an excellent little device that does ARP cache poisoning, and it redirects all the traffic through the firewall. I have a lab that is available to you to run at home where you can set up AC Hunter Community Edition at home, where we use BetterCap to do ARP cache poisoning to route traffic through your RITA AC Hunter Community Edition sensor as well. All right. The other thing that we can look at is user agent strings. Many of the different systems, when they communicate out to the internet, they're telling the different web servers, I am this specific browser. This is the type of encoding that I can accept, so they can negotiate the communication between the server and the client. And these user agent strings are used to identify things like, what is the operating system? What is the application that's making that request? Most of the time it'll be a browser. Sometimes it may be just a simple little like Roku device or a Chromecast or something like that, or even IoT devices. The really interesting thing is malware tries to emulate user agent strings, but sometimes it doesn't emulate it perfectly for the host operating systems. So you may have a situation where you have thousands of computers in your environment that are using a user agent string for everyday surfing, but one of those systems is using a very unique user agent string that looks close, but it's not the exact same as every other system. That's a potential detect, and AC Hunter can help detect that. The other thing we can do is we can look at JAW3 and JAW4. This is where we're fingerprinting TLS negotiation at the beginning of that session. And this is something that came out from Salesforce. It is an excellent tool that can fingerprint known TLS SSL profiles. Even though the data is encrypted, we can look at it and say, this is a TLS SSL negotiation with Google updates or Microsoft updates. And we have that capability built into AC Hunter and RITA as well. So what we're ultimately looking for is long tail analysis. We're trying to identify the outliers in an environment, where fathead would be all of your browsers. Fathead would be all of your different applications that you're using every single day. Long tail would be that one system that's the only system using a user agent string. Long tail would be that one system that is beaconing at an incredibly consistent like interval in your environment that you can hone in and say, which of these things is not like the other? Which of these things doesn't belong? And we can drill in on those particular computer systems, looking for those anomalies as well. Also has the capability of integrating with deny lists. On the internet, there's a very large number of different lists of known command and control servers and known bad IP addresses, and deny list capability allows you to look at that beaconing traffic and see if it correlates back into known deny list environmental entries that have been put out by like Google Safe Browsing. You can incorporate that into AC Hunter and to RITA, and it allows you to say, okay, we're seeing a beacon. This system is on a deny list. We need to investigate the system more closely as well. And yes, RITA has the capability of integrating with Doug Burke's excellent tool, Security Onion. So you can run it on a Security Onion interface where it's traffic, or it's capturing all of this traffic and doing analysis, and you can do full beaconing detection as well. All right, so now we have a lab. Let me go up here. Let's go to this, and let's go just full screen. Item not needed on the slides right now. So if we can get that, awesome. There we are. All right, so we are going to do the RITA lab. All right, the RITA lab. But before we do that, I want to talk about AC Hunter Community Edition. This is something you can do on your own time. This is the free version of AC Hunter. So everything that we're talking about, we have a free tool that you can use from Active Countermeasures. And there's step-by-step instructions down here in AC Hunter Community Edition that walks you through how to set up AC Hunter at home in conjunction with BetterCap so that you have the ability to do this type of beaconing detection at home, or if you're a small business and you don't need it, you can do that as well. But we're going to be doing the RITA lab. So in the RITA lab, we're going to open up the raw data file for RITA, and you're going to look at just the raw HTML output for RITA. And what does a beacon look like? But then you're going to go a little bit further down, and we have full access to training.aihosted.com. So we can go in to training.aihosted.com, and you can gain access to this. The user ID and password is provided to you. Now, as part of this lab, it's going to ask you a series of questions relating to data sets. If you want to go to the data sets, you would go to Dashboard, then you would select this gear right here. And then it's going to open up data sets, and it's going to say, analyze the WinLab agent data set and get us the interval for the beacon of one system. And then the beacons will tell you that. You'll have some questions about DNS entries, and you can answer that question as well. So we have a number of questions that we're going to have you answer down here at the bottom, where you're going to answer some questions that normally would be really difficult. First question would be like, in the WinLab agent dataset, what is the connection interval for 10.10.98.30? In the GCAT dataset, what is the historic fully qualified domain name for the beacon on 10.55.100.111? For the DNSCAT2 JAW3 Strobe dataset, what domain has the highest lookup count and who is doing the lookups? So this is the lab. Let's go ahead. Since we have break in this and there's a little bit of a challenge, let's put 40 minutes. For those of you that are going to be doing this lab, go ahead and give yourself about 40 minutes to do this lab and get something to drink, get a beverage of your choosing, and we'll be right back. So with that, get rolling with the lab, and I'll see you on the other side, and we'll do the walkthrough. All right, we are back. Let's go ahead and let's jump straight into this lab, and we can start doing the walkthrough so you all can see it. So we probably just need the screen without me because I'm staring at my computer and no one wants to see that. So just the screen and just share that. All right, so let's go ahead and let's get started here with RITA and AC Hunter. So RITA has the capability of kicking out these HTML files that allow you to get an idea of what RITA is actually doing under the hood. Now, the important thing to remember about what we're seeing under the hood and what RITA is doing is this is the same thing that AC Hunter is doing. Understanding the difference between RITA and AC Hunter is pretty easy. RITA is the mathematic analysis engine that loads what it finds into a database. And AC Hunter is the visualization engine that shows you that analysis in a way that is easier for you to understand it. So what we're going to do is we're going to jump into the AC Hunter section, and we're going to start answering some of the questions that we asked about, in the WinLab agent dataset, what is the connection interval for 10.10.98.30? So let's go ahead and let's go into that. Let me go through step-by-step how to get here. We click, excuse me, we click on Dashboard, and it looks like I'm logged out. So let me just log back in here. Perfectly fine, normal. Once again, the credentials are provided to you in the lab in the GitHub repository. Here we go. All right, so we select Dashboard, and it takes us to an overview. Now, this overview screen is looking at a full collection of Zeek logs, and it's giving you kind of an overall rating for each of the systems that it sees. If you're working through AC Hunter, this is generally where you would start. And I am in the WinLab agent dataset, which is great. I've got that confirmed. So let's go to beacons and let's answer that question. So once again, the question was, in the WinLab agent dataset, what is the connection interval for 10.10.98.30? All right. So here you can see 10.10.98.30 we have a number of different connection intervals, right? But just like those dreaded ACT questions, which one is the most correct answer? So if we're looking at the connection interval, we have 3,723 connections at 15-second intervals. That would be our mode from a mathematical perspective. That would tell us this is the main beacon. Now, this particular beacon has what we call left drift. At BHIS, when we create malware, we either give it like a right or a left drift to kind of mess with just k-means clustering, because there are a lot of different backdoors that are specifically trying to get around that one specific algorithm. By using multiple algorithms, it allows us to converge and identify those beacons as well. So pretty cool. So that's 15-second intervals. Also, notice this histogram down at the bottom. It's the number of connections per hour, right? So we have around a little over 300 connections per hour. That is a super flat histogram. That's a really good indication that we're dealing with some type of beacon. And you can actually change that interval scale to every 30 minutes, to every 15 minutes, and so on. You can see it's a really nice flat histogram every single time. The final thing that we can look at is the data size. If you click on this, it says that all of our connections, all like 7,168 connections, have no data in the payload. This is really an indication of a beacon that is active, but it's not actually sending data. Now, what do I mean by that? So if I'm doing a campaign as a malicious attacker and I'm trying to hit thousands or hundreds of thousands of systems, I'm going to compromise some of those computer systems. And when I do, I won't be able to interact with them right away. So those systems just sit there and spin idly until I'm ready to activate and start working with those systems. So this is actually really powerful, because when management or law enforcement says, was any data exfiltrated? You can actually answer that question. And you could say, sure enough, the system was compromised, but we see no data actually exfiltrated out of the environment. So pretty cool. Next one, in GCAT dataset, what is the historic fully qualified domain name for the beacon 10, 55, 100, 111? Let's go to that dataset. Once again, we go back to the dashboard. We go up here to the little gear icon, and then we select our GCAT dataset right here. There we go. All right. Now let's go look at that beacon. So you can see that we have the 10, 55, 100, 111 data set, and we have an okay connection profile. We still have a pretty tight clustering of beacons here, like actually pretty strong at 8-second intervals. If we look at the data size on this one, you can see, oh my gosh, the data size is really consistent. We have 7,370 connections with 1,441 byte payloads. So if we're looking at this, that is not normal. And the reason why that's not normal is this particular backdoor mimics the data that you see where you like it mimics the data for looking up email in Google, right? So it's meant to blend in with your organization. It's meant to blend in with users logging into their Gmail account. But the key difference is when a general user is logged into Gmail, that data size is all over the place because the emails will be different sizes. The notifications will be different sizes. It's very rare to get a really, really strong like beacon with the exact same size every single time. It's not very likely. Now, if we look at this one, the other question that management or investigators or law enforcement would ask is, was this backdoor ever activated? And sure enough, we go over here, we can see that we have one connection that I have trouble hovering over that is over 44,000 byte payloads. So that's pretty crazy. But to answer the question, what is the fully qualified domain name? If we look here and try to zoom in, you can see that that fully qualified domain name is gmail.smtpmsa.google.com or smtp.gmail.com. So this is a backdoor that is bouncing off of Google Mail. Now, this is a backdoor that we created for the purposes of demonstrating glaring issues that exist in detective technologies and organizations, because we were seeing in our pen test that if we bounced our traffic off of Google, that very few organizations would successfully detect that, because most of the firewalls that are out there ignore all the traffic that goes to Google. And they do this for a couple of reasons, like three. The first reason why they do it is because of speed, right? You don't want to be intercepting all the traffic to Google because you're not going to do much with it. And you're really focusing on that throughput and horsepower and looking for other things. So why do all this analysis with Google, right? The second reason why they look at it is privacy. If an organization is intercepting and doing full TLS SSL interception of Gmail traffic, they're going to get private data. And some of that data may be healthcare data. So they tend to avoid it. The final reason is false positives. So if we go to an XKCD comic, this is one of my favorites. It says, Rob, you use Unix. Come quick. To disarm the bomb, simply enter a valid tar command on your first try. No Googling, you have 10 seconds. Rob, I'm so sorry. How many of you use Google on a regular basis to analyze logs, to check out how to run a command? How do we do that, right? If we were tripping alerts every time anyone in IT or security was looking up how to run a tar command or any other command, we'd be getting false positives all the time. Now, that's just a couple of cool things. Now, there may be some questions that come up from time to time, like if I'm dealing with AC Hunter, can I integrate that in with another tool like Security Onion is one that I mentioned? Yes. If you go to the RITA page, there's actually step-by-step instructions on how to get AC Hunter and RITA on Zeek. So let's look at this one. DNS-Cat2 JA3 strobe agent. What is the domain with the highest lookup? Let's go check that out. All right, so we're going to go back to the dashboard. We're going to go to our little gear, and we're going to select that data set. Okay. Now we're going to come over to the DNS entry, and we can see this particular domain right here, this 1-rx.com. Oh my word. There are 62,468 subdomains. Now, let me explain what fully qualified domain would be. If you go to www.google.com, that's a web server. You go to mail.google.com, that's an email server. Maps.google.com, that's maps. Each of these things, www, mail, or maps, are different fully qualified domain names under the exact same domain. And even Google doesn't have 62,468 external facing subdomains. So we have this weird domain that has 62,000. And the number of lookups that we have are 109,227 lookups. That's crazy. You just don't see that. Now, there are some actual examples where you do. Kimry, or some people call it Crimu, but it's Kimry is how it's pronounced, because it's Welsh. They have a service where you can submit file hashes to their DNS service to look up and see if there's any antivirus hits for that. So you can do that. So we've seen that, but it's really rare. So if we're investigating this particular series of lookups, we can do that investigation and identify which system's making all of the requests. So right here, you can see that it's all being done by the exact same system. Every one of these lookups is being done by 192.168.88.2. Now, what is the reasoning why that could be legit? So if you think about it, in most environments, your domain controller has the ability to do recursive lookups on behalf of all of your hosts. So it may not be that abnormal for you to see a single system doing every single one of these lookups in your environment, because that could be your domain controller. So we could do a quick check to see if that is our domain controller, and we can see who's actually making direct connections, not just doing the DNS lookups, but who's making direct connections. And you can see that the only system that's making direct connections is 192.168.88.2. So this is an evil backdoor in an environment. All right, so now let's kind of break from the recording. Video editors, if you're editing, you want to edit this part out, because now I'm going to talk directly to my students. Does anybody have any questions about this? It's a good time. Like I said, I appreciate you guys being with me for the recording. When we talked about the sizing of a sensor for a network, I have a 400 megabit link, so max throughput is 800. Is that a 4 CPU core with 32 RAM sensor? Like literally that one you can do with an upper end Raspberry Pi. Pretty straightforward. Is we've ran it on a gig to 2 gig network link connection as well. So can we use this for mobile phones as well? No, 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 you cannot. Unfortunately, you can't. This gets into a much larger issue. One that really, really bothers me right now. I don't know if you guys have been following the news about what happened in the UK. You have in the UK, they basically want Apple to open up their encryption. And the FBI, a lot of people don't know this, but back in December, under Christopher Wray, they were starting to have the exact same conversations with Google and with Apple, where they're like, no, 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 we want encryption. We want people to have the encryption. We want them to have that privacy, but we really want to have the ability for the United States government to crack that open. And I saw it pop up here. That's what we call in the industry a bad idea, right? Because if you create those backdoors in the encryption, it's absolutely going to be taken advantage of, not just by nation states, or it may even be taken advantage of by nation states. But it's just bad on that as well. Now, there are people that say, but then again, child pornographers and drug dealers and terrorists are going to be able to take advantage of this. And at some point, we have to make a decision, right? Are we okay with allowing bad people to use things that good people use? And my analogy that I use on this is pretty blunt. Are Can we apply that same logic to other things, right? Like you could say, well, roads are used by terrorists and drug dealers and pedophiles. So let's make sure that we can shut down roads. Let's make sure we can shut down airplanes. Let's make sure that we can do all of these things. Well, people use houses, right? Like we have houses. So should the government have full authority to be able to gain entry to everyone's house? It's really, really difficult to find these lines. And we as a society are kind of screwed. As human beings, we don't think about things correctly. And it's hard, right? Because if you go up and you talk to a number of people and you say, well, do you want privacy? They're going to say, hell yes, right? We absolutely want privacy. And then if you remember a long time ago, the San Bernardino shooters, they went in and shot a bunch of people. They found out that they were communicating on Facebook, and then people had an uproar and they're like, well, how come the government wasn't watching this? So you have this sort of like reactionary thing where it's like, well, I don't want bad people using this. And then at the same time, you're like, well, I don't want, people looking at what I'm doing. I only want it to be applied for bad people, right? And to give you an idea, like in computers, we've been dealing with this for so long. There's actually a RFC that is basically an April 1st RFC created by Steve Belvin, where he talks about how we need to have an evil bit, where we have a bit in the TCP/IP header, and bad people, when they're doing bad things, will flip this bit so we know that they're doing evil things, right? It's just kind of ridiculous. So you could see that RFC. Some people will share it up in the links here in a couple of seconds as well. So it's something we have to think about. And honestly, it ain't simple, right? It is not simple, because if we have a massive terrorist attack and all of it was done and coordinated over an encrypted app, you better believe that people in America and around the world will be like, well, we need to have access to that to make sure that this never happens again. So some things to think about as I'm getting older. Fewer and fewer of these problems are my problems to solve. And I hate to have that and be like, well, not my problem. But especially the younger generations, we've got to figure out how we're going to deal with this moving forward. All right. So there we go. All right. So we got done with that. Let's go back to our slides. Let's go to File. Oh, no, it's View. I should just use the hotkey because it's so much easier to do that, right? All right. So now let's move into user entity behavioral analytics. And now we're moving back into me talking. If you do have questions, please put them in. Do @StrandJS, and then I'll pull those questions out. And like I said, I will answer your questions, but it'll be like, some people ask X, Y, and Z, and we'll do it that way. So we have video editors going through and cutting this for on demand. So just once again, I apologize for that, but it's kind of cool. All right. So user entity behavioral analytics. All right. So when we're looking at logs, individual logs by themselves are kind of hot garbage, but they really are, right? Like if you're looking at the standard event logs on a Windows computer system, you're not really getting the level of detail that is required for you to be able to investigate those logs properly. Unless you're enabling something like Sysmon, which we're going to talk about a little bit later and show you why we get proper logging from something like Sysmon. But in Active Directory, it gets a little bit better. We have some logs that we can use to help identify what is happening at the Active Directory level. But still, looking at a log by itself usually doesn't give us enough information to truly tell the narrative and to tell the story about what we are getting out of those logs and trying to understand what's happening. So we're looking at UEBA. It's almost the entirety of the MITRE attack technique matrix, right? If you're looking at like initial access, execution, persistence, privilege escalation, if you're looking at a large number of the different UEBA products and oftentimes add-ons for tools like ArcSight and Splunk and Elastic, it has the capability to correlate and fuse multiple different log sources together to be able to tell a story, to be able to tell a narrative. So let's play a game real quick. All right. So let's play a game real quick. I want you all to think about somebody sits down at their computer system and they turn on the computer and they log in. Like I have this computer right here. So it's part of the BHIS Active Directory. No, let's go away. It's part of the BHIS Active Directory infrastructure. Super excited about my new computer. It's running Fedora. It's super lightweight. It's a great little computer. So I sit down, turn it on, and I clickety-clack, and then I log in. Where are there logs associated with that, with me turning on this computer and logging in? What do we have? What do we have for logs, right? So just think about that, right? I'm going to have logs in the domain controller because my user account is authenticating. I'm going to have logs on the endpoint itself for me turning on that computer and logging in. But I'm also going to have logs on the switch in the content addressable memory table. I'm going to have DHCP logs when my computer logs into the network. I'm going to see those dynamic host configuration protocol logs. I'm going to have DNS logs where the system starts connecting out to the wider internet. I'm going to have web proxy logs. I may have remote terminal logs. I may have application logs, web logs for me surfing the internet. You'll see all of these logs, connection logs in Zeek. See, my point in that, one example of somebody sitting down, turning on and logging into a computer system, we can't tell that whole narrative with just one log. It requires multiple logs from multiple different data sources to tell that story. And that's the same thing with user entity behavioral analytics. We're looking at the context associated with those logs and that event associated with those logs to be able to tell us what is actually happening. But as I mentioned, logs are a train wreck. There's absolutely no log in Microsoft that says you've been hacked. Just doesn't exist. There's no, 666 event ID. Satan. It's not real. Doesn't happen. It's just not a thing, right? And I always like to say that the Windows event logs that you get from a Windows environment are basically, it seems like crack addicted squirrels or monkeys were put into a room, an infinite number of them, to type on an infinite number of computers to develop a logging facility for Microsoft Windows. And this is what they came up with an infinite amount of money. If you don't believe me, a tremendous amount of money and cocaine was used in this particular project. Just do a Google search for Steve Ballmer, developers. Yeah, things were crazy back in the late 90s, early 2000s, and the logs are just garbage. They're just absolute trash, right? If you look at logs and log analysis, many statistics of, incidents and organizations that come from Mandiant, Verizon data breach, it's less than 5% of detects come from logs themselves. You'll get a detect with your EDR, you'll get a detect from a firewall, but just pulling off the logs and saying this system's been compromised, 5%. That's scary. That's scary. And Linux ain't much better. Because if we're looking at Linux has the capability of doing like bash command line logging, which is pretty cool. but you don't get dates and timestamps unless you modify your bash environmental settings to get those dates and timestamps of when people actually ran those commands. Now, as I mentioned, Sysmon, super cool, should totally be running it, but Sysmon works on Windows and it's currently in an early developmental phase on Linux and Unix as well. So JP-cert was one of the first groups of people, and they're out of Japan, that's JP and the JP-cert, that started looking at this and started blowing this thing wide open and fundamentally changing the way that we look at logs, log analysis, and logging. Because really with this particular group, it was the first time that there was a coordinated, sustained effort where somebody said, you know, let's got an idea. Let's actually go through and run attacks and look at what happens whenever an attacker uses something like WMI, or they use PSExec or WinRM. See, these are all built-in utilities that are on Windows computer systems that you can use to be able to make connections to other Windows systems for lateral movement in that environment. And JP-cert started recording what are the registry key changes, what are the different files like prefetch that are modified, what are the different events that are generated on that computer system based on those tools being activated. And this was amazing because it showed that there are multiple logs, once again, on the individual host and on the domain controller that tell the entirety of that story about that particular attack or the usage of that tool. So if we're looking at UEBA, we're looking at a collection of logs to try to tell the entire narrative of that computer system. So we look at it across multiple logs, can require Active Directory, Exchange, Outlook Web Access, also IIS logs sometimes to tell the narrative and the story. And it often requires a variety of different log tuning techniques to make sure that we're getting the right logs. In a little bit, we're going to talk about how we can enable PowerShell logging and how we can enable command prompt logging on a Windows computer system. Just as a spoiler, it's not a checkbox that you enable and it magically works. It's like some kind of Rube Goldberg machine to try to get these things working out there as well. So when we're trying to visualize lateral movement, when we're looking at the lateral movement type of attack, we have this round red computer system in the upper left-hand corner, SVC white noise. And that system is logging on to all the green triangles, which are all the individual workstations. So now you have one user account that's logging into dozens of additional workstations. There's no one event log that actually tells that narrative story. It requires all of these different event logs of all of these different systems, all communicating back and correlating that through a UEBA to say, we have this one account that is now logged into multiple different computer systems simultaneously. And that would be something that absolutely should be elevated to being reviewed and analyzed by an analyst. So false positives, when you're looking at logs and log alerting, false positives are not a thing. Now, I know this kind of makes some people's heads explode, right? Like, what do you mean? False positives are absolutely a thing. No, they're not. No, they're not. See, it's usually a concept of tuning, right? So I try to get my team to stop using the phrase false positives, right? I'm constantly saying, no, don't call it false positives. We call them detection tuning opportunities, right? Because if you have an alert that is generating, it's usually something specific to the customer environment that's causing it to trigger. So let's say that we go back to this slide. I have an account that's logging in simultaneously to dozens of computer systems. They investigate it and they say that SVC white noise is not a malicious actor. It is actually a legitimate service that is being used in that environment for legitimate reasons. If we call it a false positive, then you would just shut off that rule completely. But that would be a mistake. That means an attacker that uses the exact same type of technique to move laterally could then use that and we'd be blind. So we instead call it a detection tuning opportunity, or DTOs, where we can go into that rule and say, this rule does not apply to SVC white noise coming from this particular server where it logs in from. We're going to tune that. And that is our job. We're going to tune out those service accounts. We're going to tune out the help desk accounts. Systems administrators going to be looking at scripts and backups, but it's tuning, tuning, tuning. That is literally our job and what we should be doing as part of our investigation in an environment. Now, how does UEBA work? Well, there's a number of ways that it actually works. I want you to think of the easiest example of stacking algorithm. Every time that SVC white noise account logs into a system, it gets a value of +1. Every time it logs out of a system, it gets a value of -1. So if I'm a normal user account, I log into one system, access a couple of different shares and some servers. I maybe get a +3 or +5 throughout the course of a day because I'm accessing SharePoint, I'm accessing another file server, doing all these different things. Now, if we go back to the attack, if all of a sudden the John Strand attack is now, or not John Strand attack, the John Strand account is compromised, and now it's logging into 5,000 systems, I now have a +5,000. Oh my God, it's at 5,000 and it's rising. That would be an alert, right? So we can tune that type of DTEK to say, what is the number of stacks or the value that is normal? Is it 5? Is it 6? What is that value out there as well? This also ties back to understanding how real attacks work. You see, a lot of people will be like, well, let's set that threshold as low as we possibly can. You can try to do that. You can try to do the log limbo. You can do that. However, if you know what a real attack looks like you're running Bloodhound, you're going to see that it's not a matter of like 10 to 20. You're talking hundreds, if not thousands of logins as well. Now, AI can go through and it can look at the normal paths and the normal behavioral patterns for like John Strand. So if I go into my system and I turn it on and I log into 4 systems a day and I do that every day, we're creating a weighting around John logging in as a value of 4. And we're giving it a stronger and stronger and stronger weight. If John accesses 10, 15 files in a file share every single day, we're creating a stronger and stronger weight for the number of files and the types of files that John Strand accesses during that day. So we create and baseline that normal behavior for that user. Because if we have an Edward Snowden situation where all of a sudden the John Strand account is now pulling down every single file on a file server, that is well outside of the bounds of what John Strand does normally. And AI algorithms will say this is well outside of the realm of what we see normally. We need to generate an alert and it needs to be investigated as well. So now we get into a question of where exactly are your logs? I mean, it's time to pull your logs. I mean, all of them: system, servers, services, network logs, log, log, log. It's log, it's log. It's big, it's heavy, it's wood. It's log, it's log. It's better than bad, it's good. Everyone needs some logs. All right, I shouldn't be using Ren and Stimpy because apparently that dude that created Ren and Stimpy was insane and very mentally unwell. Who would have known by watching the show? Like, if you want to know what the 90s were like, Ren and Stimpy kind of sums it up. It was weird, folks. It was weird, but it was awesome. Weird, but awesome, right? So we get these logs. Once we know where our log sources are, run attacks and adversarial emulation to be able to see what logs are generated with that particular attack. And then sit and look at it and say, how can we generate signatures based on this attack methodology? So we drill, drill, drill to make sure that we're getting the right logs. So Active Directory logs. Active Directory for most of your attacks, when we're kind of comparing this back to the MITRE attack technique matrix, those Active Directory logs are without question the single most powerful logs you have, because they do give us some very valuable things. Like if the John Strand user account logs in and then that Kerberos ticket is then used on multiple different systems, your domain controller is going to log that. So we get an idea of what are the users doing and how often are they actually authenticating in that particular system. And that is powerful, but it's noisy. And UEBA helps, but it doesn't completely cut through. It really requires you to, once again, tune the UEBA. And this gets back to one of those things that kind of triggers, like Brian, I say I'm old and I feel ancient in this particular industry. And when you're looking at it, when I was growing up in the security industry, we had nothing but a bunch of Perl scripts and syslog. You would have a syslog server, all the different logs would go to a syslog server, and then you would write a series of Perl scripts to parse out the logs by hand. And that's what you had. Now you have organizations that they look at 100 false positives or 1,000 false positives a day from their UEBA. And they look at this. Look at this. This is like Like work, get in there, dig. That's our path. Because you know what's harder than tuning UEBA? Working an incident without UEBA. See, you're going to put the work in. You either do the work up front when there's very little stress, or you do the work on the butt end when an attack happens and you're stressed to the absolute max. Trust me, you want to do this on the upfront for trying to detect it. So once again, telling that narrative. Going back to Logon Tracer as an example tool, we have the red user accounts that are logged into the diamond green systems, and we can see what other user accounts that attacker or that red account has access to. So we can get that visualization and that map of what exactly is happening on those logs. You can also get stacked ranking from many UEBA, like which account is logged into the most systems, which workstation is logged in to the most systems. You can see that stacked analysis and start with trying to understand and create the filtering for those different systems. Logon Tracer and other really good UEBA tools have the capability to give you a timetable of when a user account was logged into things. This is very powerful because it'll tell you, let's say the John Strand account was compromised at hour 15. Once it was compromised, it then logged into 4,000 systems. You can pinpoint the exact start of many incidents when you can look at this timetable of what's going on. So now we're going to get to a lab where we're going to do some analysis. We're going to be using a tool called Deep Blue CLI. And this particular tool is created by Eric Conrad. And it's kind of a stand-in for UEBA because it does that type of analysis of the logs to find patterns within the logs themselves of attack methodologies. So we're going to be doing a couple of different labs here dealing with log analysis, starting with just Deep Blue CLI and the default logs that come with it for articulative purposes. And then we're going to reuse Deep Blue CLI to look at the logs associated with an attack. So we have two separate logs that we're going to look at. But Deep Blue CLI also incorporates Deep White CLI that it can incorporate logs from Sysmon, where we can get file hashes and we can check with VirusTotal to see if those file hashes are known as any malicious attacks. So this is an example. I run Deep Blue CLI. It comes in and it says that we have multiple failed login attempts for Bertha Schultz in the middle of this screen. And that's really cool. So I can see that she's logging into 75 systems. That's pretty crazy. And then I can do some quick PowerShell scripting to run that against the event log to match the string Bertha Schultz out of the event log with the ID of 4672. And I can see every single authentication attempt that her account tried to log into multiple systems. So very powerful. And as I mentioned, Deep Blue CLI now also has the capability of doing Deep White CLI, where it will go through and do Sysmon analysis because we're trying to find this. We're trying to find this. And these tools are great as a step-in for your UEBA tool, whether you're using Splunk, ArcSight, Huntress, any of those different tools that have this type of capability built into them. So let's go ahead and let's get into our lab. We're going to do two of them right now. We're going to do one, then the other. The first lab that we're going to do is going to be the Deep Blue CLI lab. We're going to do these two back to back. Zoom in here. So we're going to do Deep Blue CLI, and then we're going to follow it up with domain log review. So Deep Blue CLI is going to show you what type of really in-depth analysis you can do with looking at logs, especially PowerShell and command line logging, to detect potential attacks, far beyond just matching signatures in a file. Then domain log review, we're going to detect a password spray for a login anomaly so you can see that it'll generate and say, hey, here's a system that's doing weird things. And then you can go back to the event log and go to the ground truth of the event logs to figure out what's going on. So we're going to do Deep Blue CLI and domain log review. I'm going to put those at the top so you all can see it. Let me zoom in some more. I wonder how far I can zoom in here. I think we can get pretty far, actually. There we go. So we're not going to do Velociraptor. We're going to do Deep Blue CLI and domain log review. All right, so these are the two labs that we're going to do. And then when we get done, we're going to put, what do we got for time? Let's go ahead and we got 40 minutes. Let's do, Yeah, 40 minutes sounds good. Let's do 40 minutes on the clock and start it for you guys doing this lab at home. And then I'll resume and I'll do a full walkthrough of how to do these two labs and what we are gleaning from these labs. Please remember that Deep Blue CLI is not necessarily a tool you're going to run in your enterprise. It is literally a tool to kind of stand in to show you what type of analytics good solid UEBA can use to be able to let you know what attacks are actually happening. All right, so let's set the clock. Let's get rolling, and I'll see you in 40 minutes, everybody. All right, so we're going to start with Deep Blue CLI, and then we're going to move over to domain log review. So we're really going to get into what it is we are looking for whenever we're looking for these attacks. Oh, they're starting up already, so that's good. So we're going to have a few seconds for this to get running. So I'll kind of walk through at a high level what Deep Blue CLI does, and then we're going to walk through this lab, and then we're going to see how that fits in to actually doing a full analysis of a compromised environment. Now, to kind of set the stage a little bit, we are not using Deep Blue CLI as a tool that is designed to be this ultimate tool that you should be using in every single enterprise. It is merely a stand-in for a UEBA solution. Because if you look at what Deep Blue CLI does, it does a lot of very, very interesting things with the logs, where it looks at like the different types of encodings that are being used, where the characters that are being used, detecting password sprays, detecting password brute forcing. And we're going to go through each of those and we're going to explain them in a lot more detail. So that's the Deep Blue CLI lab. Now, the next one with the enterprise log analysis lab, that one's a bit different because that is actually showing you what a real attack looks like. And I think a lot of you would like to see, what does that attack look like from the attacker's perspective? So if you want an idea of what the attacker's perspective looks like, we have this really cool webcast called Attack Tactics. I think it was Zero to Hero. This is with Jordan and Kent, where they went through an entire attack all the way through from the beginning to the end. So they go through, how do we set up a password spray attack for gaining access inside of that environment, spraying on the inside of that environment, gaining access to user accounts, and doing that kind of brute force exploitation of that system. So I'm going to share this link inside of Discord so you all get an opportunity to be able to look at what this attack looks like from the attacker's perspective. I'm also going to throw it in resources as well because I think it's important. Now, as I mentioned, this is showing you the attacker side. On this side, we're going to be showing you the defender's side for detecting that particular attack. So we're going to get to know the Deep Blue CLI tool, and then we're going to leverage that tool to actually look at the logs of a real life attack that happened in an environment. So we have about 14 seconds left where both of our VMs are going to be up and running. Please do me a favor, whenever you're running your VM, be sure to destroy them when you're not using them. Like at the end of a lab, it's just always a good idea to destroy those VMs. So I'm now going to connect via RDP, via Guacamole, and I'm going to get my command here ready to go. So we're going to be running a PowerShell prompt right here. You can say it's run PowerShell, and we're going to CD into the intro labs directory to start. So we're starting up our virtual machine in the cloud. And meta CTF takes a couple of seconds. There we go. Waiting for my icons to come all the way through. Still loading. There we go. So I'm going to start PowerShell. I'm going to go ahead and hit yes to that. We got PowerShell doing PowerShell type things on the system. Takes a little while because it's still spinning up the computer. Don't panic. It's fine. We're just running hundreds of people simultaneously in the cloud. Just takes a moment. There we go. Now I'm going to CD into our labs just like the instructions say to do. And then we're going to CD into Deep Blue CLI master. So we have our intro labs directory, but in there we have the Deep Blue CLI lab master directory where we have the logs we're going to analyze, and we also have the domain logs as well. So I'm going to set the execution policy unrestricted. So it doesn't really care all that much about security for the PowerShell execution on this particular computer system. So we're doing a policy change. We're just going to do yes to all. There we go. Just accept that. So just pesky security just gets in the way. So now I'm going to do deep blue and we're going to do some analysis on the built-in demo logs that come with deep blue CLI. And for that, I'm going to zoom in just a hair so you can see it. So now we're looking at a new user added to this computer system. Let's take a few moments and let's look at this and see if there's anything that jumps out at you with the new user being added. Like, look at the user that's added to the administrators group. That's kind of weird, right? Got a dash user account. That's not really crazy at all. No one should be worried about that. It's very common for attackers to try to create user accounts to maintain persistence that looks strange as well. Now, a lot of people will ask, once again, what is the situation that we use Deep Blue CLI? Would we use it in an actual enterprise? The only way that you would ever use Deep Blue CLI is if you have no other options, or maybe as a secondary analysis to pull down the Active Directory logs for potentially detecting malicious traffic. Otherwise, you would be running your own enterprise SIM that does the same types of things that we're talking about here with Deep Blue CLI. Like I said, Deep Blue CLI is a stand-in for the tools you should be running in your environment. Now we're going to do a password guess. Once again, your UEBA solution should be able to detect password guessing. So I'm going to go ahead and paste that in. So let's go ahead and copy this command. And then we're going to paste it directly in here. And I'm going to zoom in for everybody. Now, password guessing is fundamentally different than password spraying. Password guessing is where I attempt to gain access to a single user account by rotating through thousands, maybe even millions of potential passwords, right? Now, in many environments, it's very, very difficult to do this. And just spend a couple of seconds. What would be some of the reasons why this would be very difficult to do? Just think it through, right? Yeah, account lockout. In many environments, if I have 3, 5, possibly 10 failed login attempts, it's going to lock that account out. Now, in this particular situation, we don't have to worry about that because we're going after the administrator account. Now, a couple of quick notes on the administrator account. You cannot log in via SMB with the administrator account. The only way you can log into a Windows system administrator account is either A, directly at the terminal at the keyboard, or B, over remote desktop protocol. And yes, you can try to do brute forcing of the local administrator password from RDP as well. So you generally can't do that, but you can see that we have 3,560 failed login attempts on that as well. That's that. If you're ever thinking you can't lock out the administrator account, that is generally correct. For vast majority of organizations, you cannot log them. Does it apply to the domain administrator account or just local? Just local. If you're thinking this through, like, how does this apply to domains? Well, you can lock out accounts that are domain administrator accounts. You absolutely can, but you can't lock out the local administrator accounts. So now we're going to try to do a password spray attack. Just kind of riff on that a little bit more. Let's say hypothetically someone asks a question that's like, you know, what's stopping brute force attacks from the local administrator account? What's usually stopping that is lapse, which allows you to randomize the local administrator account for every single system, number one. And number two, the fact that you can't log in remotely to those systems over SMB. So those are the two main protections that are out there as well. Another fun fact, a lot of people don't know, if you have a system with no password, let's say RDP is not enabled, just no password, you also can't log in remotely over SMB. Just a trick that I've learned over the years teaching, where people are like, hey, set a password and set one that you'll remember. And they're like, well, I'm going to leave it blank. And you can't log in to a system remotely over SMB with a null password. So now let's take a look at password spread. So as I said, a password spray is a different sort of creature. A password spray is different than a brute force password attempt because a password spray is flipping it. I'm not trying to log into one account with thousands of possible passwords, but instead what I'm doing is I'm trying to log in to multiple user accounts with a single password. And usually that single password would be something like season and year, as one of the examples that we see again and again and again, or company name 123. So here you can see that the user account JWrite was logging in from a specific desktop and was trying to log into all of these other user accounts, probably with the exact same password, right? So that is what a password spray looks like. And we're going to come back to that one in the event logs here in just a couple of seconds in the second part of the lab that we did. Now let's talk a little bit about encoding, right? A little bit about encoding and what we can do to detect the encoding in a environment. Now, this also is kind of part of that UEBA, where we're looking at the different ways that attackers can attempt to obfuscate the execution of their commands. Now, once again, this is something that is absolutely essential to understand, that what an attacker is doing and what your SIM needs to do is it needs to look at a command not just in the contents of doing a perfect string match of that command, but rather trying to look for things around that command where an attacker tries to obfuscate. So an example would be here, the attacker is doing camel case. They're doing upper and lower case and adding in some really weird spaces. Oh, speaking of weird spaces, look at this one. This one says PowerShell event ID 4104, suspicious command line. It says the long command line is greater than 1,000 bytes, which is strange in and of itself. And it says possible command obfuscation, only 6% alphanumeric and common symbols. Why is it looking at it like that? Look at all the white space at the beginning of it. Look at my field and notice it is barren of any commands to give, right? So if I scroll down, eventually after this white space, I get into the actual command itself. Now, why would an attacker do that? Usually when an attacker is attempting to do that, they're trying to get around the buffer analysis in some SIMs and also in some IDS IPS tools, where they're putting a bunch of white space to try to basically get around protections relating to buffer overflow attacks. Kind of an old technique that's been around since the libwhisker extensions released by Rainforest Puppy decades ago. The next one, we're taking each of the different characters and we're encoding them. And when we're encoding them, we're putting them into an array. We have like, we're going to execute character 73, character 69, character 88, character 32, character 40. And you can see that plus symbol is where we're concatenating those together, one character at a time. Pretty crazy. Next one, yeah. Yeah. So your computer knows what this is, but as a human, not so much, right? We're just encoding it with a bunch of other meta characters. Then we're doing the same character trick, but instead of doing character 20, character 24, character 5, character 125, we're loading that up into an array and then loading it into character. Next one is base 64 encoding. We're just using straight up base 64, no big whoop. It's fun. More encoding, we're using binary encoding. And then we have more character arrays and different types of encodings as well. So a number of ways to look at trying to detect what are the different types of encoding of commands that execute. Now, once again, this requires your UEBA to have a little bit better context to understand how these actually work, right? It's not enough just to find a signature string, right? It has to go through and take a look at what that particular command is doing, what is the makeup from a mathematical perspective of characters, and how that relates to a potential attack string. So that gets us set up with Deep Blue CLI. Now let's actually play with it. Now we're going to do domain log review. We're in the Deep Blue CLI master already. So now let's give it a real log with a real attack. All right. So for that, we're just going to put it in here. I'm going to zoom in. Zoom. Oh, I didn't copy it correctly. It's weird. Copying and pasting from one tab to the other, like Control C doesn't work so well. You got to go right click, copy, and then literally the first thing you do once you get into the terminal is right click to load the value, which clearly I did that wrong by talking about it. It didn't like that. All right, so we're going to right click, copy, and then we're going to come in here. There we go. Character return line feed. There we are. So let me zoom in. So now we're looking at that actual attack that we talked about in Attack Tactics 5, where you're looking at a real password spray. So here you can see that we have multiple admin logins from one account, and we have lab DC2, and then the number of total login failures is 232, and that's within a very tight window. And Deep Blue CLI is really good at kind of analyzing those tight windows and coming up with, hey, there's some weird shenanigans. I call shenanigans on this particular pack in this event log file. So we're going to go into Event Viewer, and what we're going to do is we're going to look at the event log. So I got Event Viewer starting. I'm going to open up Windows Explorer, and we're going to go to C, and I'm going to go to Intro Labs. There we go. Then we're going to go to Deep Blue CLI, and we're going to go into event logs here. And now we have to open up the DC2 seclog with domain password spray right here. So we're going to open up this one. To open that, we double click it, and it's going to open up our event viewer here in a second, and it's going to open up those event logs associated with that attack. Takes a little bit because they're actually compressed, so it's decompressing them, opening them up. There we go. And I have the DC sec logs here. Select those. And then I can sort on the event ID. And I can go down to the bottom. Oops, wrong way. Sorted one too many times. Let's scroll down. And we can see all these credential validations. And when you're looking at these credential validations to get a little bit more information as far as what's going on, you can see that we had a failed login attempt from Tamara Armstrong, Lionel Vaughn, Dwight Burns, Jill Roberts, Carmen Chambers, Jody, Corey, Cora, Virginia, Leslie. And you can see that these failed login attempts, if we're looking at the date timestamp over here, is like way super tight. Like, look at this. It's like 5 failed login attempts per second, which is going on. And we can actually get what is the workstation. So like our next steps would be, okay, we need to isolate this workstation very, very quickly. And probably start trying to pull some network traffic logs to try to identify what is the system it was communicating with on the wider internet as well. All right, so one of the questions that I get a lot whenever we're looking at these things is where can I find more evidence files of different things like network threat hunting and also possibly some event logs. So if you go to the AC Hunter website, you can actually go to education and go to blogs. And we have this whole wonderful thing called Malware of the Day, where we go through all of the different types of malware that exists. And if you do just a search for Malware of the Day, like so, we have a lot of malware that you can analyze from a network packet analysis perspective, like more than you'll ever get to go through. So you get an idea of what real attack packets look like. So that's pretty cool. Also with our webcasts, we do these incident response training webcasts where we create events, and like here's one that is hunting DC-CK, SharePoint, and Kerberos attack. So you can take a look at that one, which is an additional lab where we talk about how we poison the well and doing incident response and how to walk through it. And then I also have another lab that is from a webcast that I did where we look at firewall log reviews. Where is that one right here? Firewall log review. So we have a lot of labs in here, and I kind of drop them into the different classes. This is reviewing an ASA, Adaptive Security Appliance from Cisco, and their logs. And I thought I had another one. I might need to try to get that sunk in here and get it loaded. But we have a lot of these labs that we do, and also subscribe to our webcasts so you can actually see those as well. So there's a lot of stuff in here for you to plan and learn and try to get better. So I'm going to talk a little bit more about event logs, and we're going to jump into another lab to close out the day. So just give me a second. That's fine. Let's go view, and I am going to go enter full view. So one of the questions that we get a lot is what can be a recommended free and open source and affordable UEBA? Honestly, there's not a lot of options in this space at all when you're talking UEBA. The big ones that you can look at would be Security Onion, and also I would be looking at Waza as an EDR that you can run as well. And we'll talk about that a little bit more as well. All right, so let's talk a little bit about proper Windows event logging, and then we're going to talk about how Sysmon makes a lot of this better. So we've got a wonderful little list for you to look at for 4624, 4663. These are event IDs that you should be looking at in your environment. Some of them, like when you're looking at 4662, ACL object access, that one you want to be careful of because it can overwhelm your logging facility. Usually you'll turn on that level of analysis on a specific directory with specific files as part of a honeypot strategy. But we got a bunch of them here that you can look at. But I do want to ask a couple of questions as we're working through the logs and log analysis. How much does your organization actually log? Right? Are you logging terabytes? Are you logging multiple gigabytes of data? How much are you actually logging? Now, some people say not enough. That's a good answer. So what do you log from is another question that comes up from time to time. Now let's get into some really difficult questions. Who are the people that dictate what the logging standards are in the industry? Who are those people that sit around and tell us this is what you should be doing? Yeah, they're regulators, right? Or they're different compliance standard groups. So a lot of these compliance standard groups that come up with the regulations and how we're going to do things, they go to industry experts. And if they're trying to find industry experts associated with logging, they many times go to log vendors. So many of your log vendors tell you log everything. And then they sell you data lakes and data oceans and all these data things, right, that you deal with. And that creates monster issues. And the reason why that creates monster issues is because we're now in a situation where the people that stand to make the most money off of us logging absolutely everything are telling us to log absolutely everything. And one of the things they'll tell you is, well, it's better to log too much and not need it than log too little and need it, which is garbage. Because usually if you're looking at the amount of logs in your environment, just a quick question, what percentage of logs actually have an alert, signature, or report associated with them? In many organizations, it's around 5 to 10%. So that means that you have like 90 to 95% of your logs are just garbage, that you don't have an alert, you don't have a report, you don't have a signature associated with those logs at all. So we've got to be doing better about that. So it can be argued, and I somewhat agree, that we can do things like enable command line logging, right? Well, we can go through, we can set up getting command line logs and PowerShell logs, just like we talked about in that lab where we were pulling those logs from Deep Blue CLI. Now, Deep Blue CLI really a super cool tool. It's giving us the ability to parse those logs from the command line from PowerShell, and that's wonderful. We should absolutely be doing that. But the problem is Microsoft doesn't make it easy for us to do that type of logging. So what we're going to do is we're going to take a 10-minute quick potty break because we're at the top of the hour. We're going to take 10 minutes. We're going to come back and I'm going to talk about what it takes to enable command line logging on a Windows system. And then we're going to talk about how we do PowerShell logging on a system. So let's take a quick break. We'll resume. We'll talk about command line logging, kind of made easy. All right. So let's go ahead and let's get started talking about command line logging easy. And you can see we're being a little bit sarcastic at this particular point because, well, we got easy struck through. Now, the easy part is kind of frustrating because you would think the command line logging would be an incredibly powerful tool for anyone that's working on a Windows computer system to figure out what's actually happening. We're looking at command line logging. We're looking at PowerShell logging. These are things that absolutely should exist on a computer system. But let's kind of look at the problem statement just a little bit more. See, if we go over here to the Windows logs and we take a look at like the application logs, you're really not getting a lot of very valuable data out of this. And this is the thing that blows my mind. Like there's a whole bunch of people that talk about, well, if we enable command line logging, it's going to be a lot of logs. Or if we enable PowerShell or Sysmon logging, it's going to be a lot of logs and that's going to be a problem. People aren't going to be happy. Once again, Dogs and cats living together. That's not fun. All right. But let's take a moment, let's just take a beat, if you will, and let's take a look at what it is actually logging, right? Like here, I've got this one event log that says Office down level migration succeeded or offline down level migration succeeded. I don't know what the hell that is. Here we've got DB token, DB, the database engine attached to database one, DB token, and here's the internal timing sequence. Like instead of command line logging, someone's like, we really need to have the internal timing sequence for the DS token for the database engine attached and kicking that out, right? I mean, look at this stuff. SVC host started up a new instance. Well, what instance did it start for services controller host? We've got more DBS tokens. All right. So that's successful auto upload of a third-party root list with effective date. Which third-party root list? Root list of what? Like that's just application. If we go over to the security logs, it's equally bad, right? Like we just have horrible things here where we can see security enabled local group membership was enumerated. Okay, that's kind of valuable at that point. Special privileges were assigned to a new login. Oh my gosh. Okay, so here's the deal. With this particular one, I actually know what this is. So if you go in and you change group management, if you access the event viewer, if you access group policy configuration settings, it never makes it so that change was made by the user that did that thing. Instead, what you're going to see is the system's going to make those changes, and you're going to have a user that invokes privileged use who's going to make those or request those changes to be made by the system account on the computer. Why is it that way? Because Microsoft hates you. And the other reason why it's like that is because, once again, cocaine, right? User account management, enumerate credential details. I didn't do any of this. This is just stuff that's happening in the background on my account again and again and again. So you really don't have good, solid information about what is actually going on your computer system as it relates to somebody trying to do security troubleshooting on that computer system. So you would think that enabling command line logging on a Windows computer system would be exceptionally high on the priority list to make it easy. Well, Microsoft doesn't. Now, over these next few slides, I really want you to understand that we're not giving you all of this so you have the ability to go through this and do this on your own. We're basically showing you all of these different things to highlight the fact that this sucks and it shouldn't be this hard, right? So the first thing that you have to do is you must have audit process creation auditing enabled. You must enable the policy setting to include command line process for creation events. And Microsoft tells you when you do this, when you use advanced audit policy configuration settings, you need to confirm that these settings are not overwritten by basic audit policy settings. And they give you instructions on how to deconflict these two things. You need to change the size of the event logs to be a little bit more because we're logging all of those important migration downgrade events. We need to make sure we're making enough room for things that would be, I don't know, useful. Command line logging is off by default. To see the effects of this policy update, you have to enable two policy settings: admin template system audit process creation, policy windows security advanced audit detailed tracking. And once again, that second setting will most likely be actually overwritten. So you got to go back and do it again. Then to avoid that overriding, you got to create a third setting that we're going to define the domain policy, computer security, local security audit policy settings. Make sure that's enabled. And then at the end, you get this, right? Like this is what we should have been getting at the very beginning on a computer system out of the box. Like those other crazy logs that we're logging off of an endpoint, those should have been things that you turn on if you're actually doing kernel level debugging on that computer or anything of that nature. But no, those are the things that are turned on. The stuff that's useful for the day-to-day maintenance and operation of the system are not enabled. But when we get that, we get event ID 4688. That fires off on the computer system, and you can see that somebody ran the net command on this computer systems as well. So that's pretty nice. PowerShell logging, is that easier? It is, but I want you to notice that you have to run these 1, 2, 3, 4, 5, 6 different PowerShell commands to enable PowerShell logging. right? You can put that all in your own script, right? You can create profile.ps1 and it'll enable that full PowerShell logging. But don't you think it's a bit weird that we have to go through like all of these different settings to enable PowerShell logging on our computer system? But now we have PowerShell logs, right? And we get that same level of detail that is super important for trying to enumerate what type of evil is going on this computer. In this situation, we definitely have some evil because you can see that Bloodhound invocation on this computer system is firing off. So yeah, that's kind of bad if you see Bloodhound on that as well. Now, Sysmon changes all of this. This actually came out in 2014 by Mark Rusanovich. Now, Mark Rusanovich originally was not part of Microsoft. He started up a company called NT Internals, which became Sys Internals, and Microsoft acquired them for a lot of money. And the reason why they acquired Mark Rusanovich's company is because the tools that he was creating for day-to-day systems administration tasks were better than the tools that Microsoft themselves were releasing. I remember back in the day, like when we were using his tools, like it was literally a default install build. Anytime you set up a workstation for a systems administrator, that you would literally install the NT internals or you would literally install the sysinternals package on a computer system because the built-in tools on systems were just bad, just horrible out of the gate. Now, a lot of these tools, the sysinternal tools, many of them are installed, but not all of them. An example would be Sysmon. Sysmon is not installed by default. So it's literally a tool that gives you the level of security and configuration and log analysis that you need to be successful on that computer system. And you have to download Sysmon and a config. I'm going to come back to that config in just a couple of seconds. But you need to install the tool and the config. The beautiful thing is, with the power of group policy, you can put Sysmon and that config up on a file share somewhere, and all of the systems that are running that group policy can execute that executable and that config from a share via group policy. When you install it, it's going to be in the event viewer. It's going to be in the application services logs. It's going to be in Microsoft all the way down, Sysmon operational. And yes, you can get these logs off of the systems with WEC-WEF, Windows Event Collecting, Windows Event Forwarding, which, by the way, don't use those two things because they're incredibly unstable. You could also use FileBeat from something like Elastic to get these logs off the system. But now look at the detail that you get, right? And this is something we're going to do in the first opening lab of tomorrow. We're going to sit down and we're going to show you what Sysmon looks like. And we're going to run malware on your Windows computer system so you can see exactly what this looks like and why it's incredibly powerful. I'm also going to go a little bit further when we go into the next session, where I'm going to walk through doing things like dumping password hashes, where you're going to see the malware invoke local security authority subsystem service so we can get a much better process tracing of what an attacker is doing on the system. But if we look at this, we're getting the date timestamp. And out of the box, the date timestamp that we're getting is UTOC, right? We're getting it Greenwich Mean Time. We're not going to the local time of the system. We don't have to worry about clock drift. It's all tied to a specific time zone. We're getting the process ID of that process. We're getting the image. So you can see it's users sec504 downloads MSF. We're getting the name of that executable. This one's in honor of sec504 from the SANS Institute, which is one of my favorite classes I've ever taught. Currently being ran by Joshua Wright, who is the new Dread Pirate Roberts. Ed Scotus was the original Dread Pirate Roberts, and I remember teaching at conferences, and I'm not making this up. He literally would tell me, "Good evening, have a good night, John. Sleep well, for I very likely might kill you in the morning." Would literally say that to me for years, and then I became Dread Pirate Roberts, and I ran SANS 504 for a long, long, long time. And then I handed it over to Josh Wright, and Josh Wright is the new Dread Pirates Roberts. So big shout out to Josh and that class. But this also will get you things like the file version, the original file version of the executable. It'll also get you the original file name and who created that file, who is the manufacturer. Do you remember in the earlier session when we played with AppLocker? when we played with AppLocker, we were able to look into like creating custom application control policies based on the manufacturer, the actual version, and the build of that executable. Sysmon is pulling that same information. So in this particular executable, you can see it was created by the Apache Software Foundation. And the name of that product is Apache Bench Command Line Utility. And the original name was AB .exe. So what the hell is going on here? This is just default Metasploit things doing Metasploit things. What Metasploit does by default is it takes its malware and it injects it into an executable that was previously known to be good. You can change this with the -T option in MSF Venom, where you can change that out to a different template executable. But the default template executable that Metasploit uses is the Apache Bench utility, where it injects its malware right into it. We get the full command line invocation, where it's actually executed from. We get the name of the user, and we're also getting the file hash, the MD5, the SHA-256, and the imp hash, which you can't see on the screen, but it's there. You can also see the parent process ID and what is the name of that executable. And in this example, we can see that chrome.exe invoked msf.exe as well. So very, very cool stuff. The process ID, a lot of people get that confused. Is the process ID the same as the event ID? And that's not. Process ID is a uniquely assigned identifier for every single process on your computer system, and it is randomly assigned. For the record, just because a process ID is a lower number doesn't necessarily mean that it is a younger or an older process, because these are handed out pretty much at random on this computer system as well. Now, as I mentioned, you can push this out really easily via group policy. And this is an older article, but it still works, and how you can push out Sysmon to all of your systems through group policy objects and push that out there as well. WinLogBeat, great utility for getting those logs off of the system from Elastic. You can basically point at it, configure this script, and it'll tell it to pull down the Sysmon logs and then ship those to an Elastic instance, because a lot of people are using Elastic, Logstash, and Kibana. Now, if you're trying to write signatures, there's a lot of resources from a number of different excellent groups that'll help you with this process. One of them is SOC Prime. SOC Prime will help you, and there's all kinds of resources for how you write signatures to do matching of potential attack strings within Sysmon logs. So check that out. Sigma, though, is the big awesome. Sigma is a product that's kind of a Rosetta Stone. It's an open source project that's sort of a Rosetta Stone, where it basically, you can write a signature in Sigma language, and then it'll automatically convert that signature to a wide variety of different other SIM languages. So you can write once in Sigma, and then you can export those signatures to Elastic. You can export them to ArcSight. You can export them to Splunk as well. So you can do all of that relatively easily. So very, very powerful. If you're just getting started in this industry and you want to spend some time kind of figuring out how to hone your skills and what SIM to use, the best thing to do would probably be to sit down and learn how to use Sigma, write signatures and learn how to write signatures, because it'll allow you to understand how log analysis works. And then you can apply those skills to a wide variety of other SIM platforms as well. So we have other logs that exist, and this gets somewhat difficult. You really shouldn't be running on-prem Exchange. I'm just going to throw that out there. Like, that's bad. So in the industry, anytime anyone's like, well, I'm going to run an on-prem Exchange, a whole bunch of people will rush to your aid and get you a drink of water, get your feet propped up, and really try to take care of you because you're experiencing heat stroke, or you're just having a stroke, one of those two things. But we do still see organizations today that are still running on-prem Exchange. It's still something that we see fairly regularly out there. But if you want to get the appropriate logs off of that, it's fairly difficult, because you need to make sure you have ETW, you have the logs files, and you have the IIS logs as well. All right, so we already did that log, or that lab. We're going to get into a different lab here in just a couple of moments. Actually, we're going to start tomorrow. We're going to get to the Ask Me Anything. In domain controllers, to detect a large number of different attacks, we recommend these 6 event IDs: successful logon, successful failure, dealing with Kerberos tickets, NTLM authentication, and then assign special privileges as well. All right, so we're going to stop here for the day. So now it's time to ask me anything on the life, universe, anything at all that you're interested in. What is the 504 equivalent on the Antisyphon side? It would probably be a combination of this class and the Intro to SOC core skills. Would be the 2 things that would tie that as well, which is weird. That's kind of strange. So that's it. I told everybody I wouldn't do this, but I'm now in the process of writing an introductory to offensive security assessment class, where I'm going to write a class with a bunch of labs that'll cover how to do vulnerability scanning, how to run Nmap, how do we do things like run nuclei for doing vulnerability analysis, how do we do web application security assessments. So that is coming up as a paid what you can class in the very near future. We'll be doing that as well. So yeah, just trying to make it simple. It's not going to be super advanced. Like we're not getting into malware creation. We're not going to get into writing 0 days and things like that. But if you're tasked with doing just basic vulnerability management on an environment, how can you get that Pareto principle to find the 80% of the vulnerabilities with 20% of the effort? Are there any reasons an org would not want you to have Sysmon enabled? Most of the time, the reason why you would not have Sysmon enabled would be 2 separate reasons. The first reason is somebody would say it's too many logs. I think that is stupid. I think that that's just dumb. I don't think that that's a good answer. The better thing that you can do is you would try to make sure that you would shut off the logs that you don't need. The second reason is if you're running Microsoft Defender with Sentinel, then it's pulling all of that Sysmon type telemetry through Defender into Sentinel. You probably don't need it in that scenario as well. What's the best way to onboard Windows logs to Sentinel if we don't have Windows Defender? Honestly, I don't know. I don't know a situation to be using Sentinel without Defender. There we go. What do you recommend people trying to get internship in the summer if they don't get an internship? That one's tough. I would recommend kind of look like following that 5-year plan and jumping in to the part where you start creating projects. Most of the people that are hiring interns, they want to make sure that there's some coding skills there. We don't at BHIS, we love people, we love what people are doing, but there's so many people out there that are hard workers and they're willing to learn quickly. And that doesn't mean a damn thing to me. I hate to be blunt about that, but I'm just going to be honest because I don't want to give you all advice that's like kind of bullshit. Like, oh, if you try hard and you're spunky, we'll see that. No, no one cares. They just don't. So I'm sorry about that. So that's why I created the 5-year plan in InfoSec Success, where we go through learn operating systems, learn networking protocols, which this class in SOC Core Skills has. And then I think it's like year 3, I say start writing code. If you can, start writing code in year 1. Learn Python. I think that's one of the easiest ones to start with. And just start writing projects and just start learning Python, doing simple, stupid things. Even if they've already been done, just do simple coding projects. Use ChatGPT as little as possible. Learn how to code because I don't hire any interns that don't know how to code. And no one else in the industry is really going to hire you if you don't understand some basics of PowerShell or Python at a minimum. Looking ahead, what are some trends you're seeing in cybersecurity in terms of what organizations prioritize to get the value out of their budget? Well, this class is really answering that question. Like these are literally the 10 things that you should be doing in your organization for prioritization. The next thing is I would recommend that reasonable guide of information security that came out from the Center for Internet Security. Check out those 2 things. I'm going to have to go through and work and try to deconflict some of those things as we progress over the next few years. But yeah, reasonableness implementation coupled with the this class, you're going to be in a good space. Please sum up what we did today and how it fits up into MITRE ATT&CK. So really we were focusing on 2 separate areas, right? The networking side dealing with command and control and data exfiltration, those entire columns. And then when we move into looking at log analysis, that's pretty much applicable to everything. And UEBA really ties into doing those. So if you can get good solid UEBA, you're going to get great coverage for lateral movement initial exploitation. If you get something like RITA and AC Hunter in place, then you're really going to work on the 2 columns of command and control and data exfiltration. What is the best resource to learn Python or any coding language? Anything you can get on your phone and you can do while you're sitting on the toilet. Anything that makes it easy for you to sit and learn is just whatever works for you as well. I really like Code Combat. It's a really cool thing where kids learn Python and then just learn Python online. There's a whole bunch of different learn coding online tools out there. 100 Days of Python and Udemy is pretty good. I think that's great. Also, Joff Thayer has a really cool introduction to Python class as well. All right. What other questions do you all have? Automate the boring stuff with Python. I haven't checked that one, but yeah, check it out. Do you think the IT cyberset job market is worse considering all the people being let go in the government? Once again, I promised you guys I'm not going to try to BS you, so I'm going to be completely blunt. And I'm going to answer that question in two fronts. Yes, it is becoming a problem. All right. So, with the federal government and the layoffs that are going on right now, and I don't want to get too political at this particular point, but there are a lot of people in the information security space that are being let go. Now, it is my belief that that's going to be temporary and it's going to be like a rubber band. There's going to be a lot of them that are let go and then it's going to snap back and there's going to be an over hiring for these cybersecurity roles that exist in the federal government. There's a lot of conversations happening in a variety of different ways, especially when you're looking at AI and automation. And there's a lot of people that are really high up in executive level, not just in the federal government, that think that tremendous portions of computer security are going to be replaced by artificial intelligence. I think that that's wishful thinking out of the gate. So there's so much complexity and there's so much work to do and there's so much attack surface out there that we're going to be looking to see a lot of people get hired, I believe, and that's me being optimistic. However, the pessimistic side of me is everyone that's in this job market needs to understand that everybody wants unicorns. Number one. And number two, and this is the most important, they're willing to wait for unicorns. So you keep on hearing about 1 million jobs in InfoSec, 500,000 jobs in InfoSec. That's true. There are jobs. There's a lot of jobs out there, but organizations are absolutely not in a position where they're super in a hurry to try to fill those jobs in computer security. Okay. So please keep that in mind when you're looking at the job market. So yes, there's a lot of jobs, but they're willing to wait for people that have the right skills. So if you're looking at this class, the SOC Core Skills class, the ATT Core certification, and then you're also looking at the cyber range and things like that, we're trying to equip people so they can become those unicorns, so they can become the people that other organizations want to hire. I am literally trying to build a better pool of people that I can pull from, and I can pull like the top 1% to hire at Black Hills Information Security. So that's what I'm saying. Yes, there's going to be a whole bunch of people in the job market, but there's going to be an elastic slap back. Most of those people, just going with what I've had in experience in administrations, are probably going to end up in jobs where they're not directly employed by the federal government, but instead employed by contractors. Because a lot of those jobs, they won't go back to federal government spending jobs. They're going to go to a subcontractor, a big subcontractor that's then going to fill it. And that gets into a longer conversation. So there's going to be a huge hiring kind of going through that again. But remember, people are looking for unicorns. Learn coding, go through these classes, get certified, go up the cyber range as much as you can. Do Hack the Box, do try Hack Me, and also be sure to check out Jason Blanchard's How to Job Hunt Like a Hacker YouTube channel as well. What are your thoughts on keeping a job in tech? A lot of layoffs and offshoring in the past years. Is anyone safe? Now, the offshore thing happens and it comes in ebbs and flows. It always does. You have this huge effort. We're going to offshore as much as we can. They realize that doesn't work as well as they expected it to. And then it comes back to onshoring. And I want to be also kind of honest, like people kind of crap on like, oh, we offshored a whole bunch of jobs over to India. Look, the talent that I'm seeing coming out of like countries like India and Romania, different places like Malaysia, these people are legit. Especially where you're looking at like parts of India where they've had really good IT infrastructure and they've had great IT training. And if you're looking at the English skills that a lot of these people are having coming out, they're just awesome. So they're upskilling really quickly. And as I mentioned, in Poland and in Romania in particular, the two places that I have experience with, we're seeing just amazing talent because the university systems will basically pay for you to get all the way through a doctorate. And a lot of those schools are completely paid for by the government entities. And I'm just seeing just absolutely badass talent out of those spaces as well. So that is a thing, right? But then that pendulum comes back to where there's a lot of companies that require, like companies like BHIS, if we're going to hire someone to hack into their network, they're not super comfortable with somebody out of Romania or India doing that work for them. So there's a lot of requirements for different jobs that it has to be US citizens. And for a lot of those things, it makes sense because it's highly sensitive stuff that they're dealing with. So it goes back and forth all the time. So just keep that in mind. All right. More stuff of unicorns. Intro level with CISSP of 20 years, 25 years of experience. Yes. Yeah, I know. Would it be worth putting our learning experience be it? Absolutely. In fact, we have seen a large number of people. I think we're coming up on over 300 people that have reached out to us and said explicitly they got a job because they went through these training classes that we offer as pay what you can. Understand that Antisyphon is literally just filled to the brim with some of the best SANS instructors that ever walked the planet, right? You have people like Chris Breton, you have people like Bill Stearns, you have people like Malware Jake, you have people like Hal Pomerantz. You have all of these different people that, you know, I'm not kidding. Like I've seen the eval scores. They're actually impossible eval scores. I'll give you an example. We had a psychometrician a number of years ago at the SANS Institute who they hired to try to develop better eval analysis. And at the time, I think we were still on a 10 scale. We might have been on a 5. I'll just pretend it was a 10 scale. And the really good SANS instructors that were presenting at large conferences, we would be in a room with like 100, 110 people, and we would get an average score across the entire class of like 9.8, 9.9. And some of us, we had a number of times where we popped perfect 10s for 100 people. Now, when you're looking at that, right? When you're looking at like that's just not possible. And they hired someone in to evaluate it. They came in and they're like, that's not possible. And they literally sat in the back of our classrooms, watched what we were doing at the evals, counted the evals, and they're like, holy crap, that's that's amazing, right? And those are the people that are at Antisyphon, right? You're looking at some of the best instructors, like Kevin Johnson is another one. I'm just kind of going down the list because I have a lot of instructors here. And those are the people that are present and accounted for in Antisyphon. So that's the quality of training. And we're looking at the AST core. We're making sure that people understand that if you were trained by us, you're getting that absolute top shelf level training here as well. So keep that in mind. It is something that people would recognize. It helps to put the instructor. So if you're saying packet decoding with Chris Breton, Linux forensics with Hal Pomerantz, because they may not know the classes, they may not know Antisyphon, but they'll know the instructors. So put it there as well. I have 30 years in IT and I've recently retired. How would I position my part as a part-time contractor? I would really focus on like, what is your expertise? And I would start by reaching out to security firms and saying, here's what I can do. Here's how I can help, and be willing to do it at like little to no cost as a 1099 to make sure that there's a match and that you can provide the skill. So what are you going to tell security firms? What are you going to tell companies that, or even just general companies you're doing security stuff for, that you're going to bring to the table, that you're going to bring value add? I'm going to be blunt with you, Fitzer. 02143. There's ageism exists. There's like isms all over the place. And there's absolutely good old boy network. There's ageism, there's racism, there's sexism. All of these things exist in all these different places, and we're never going to make those things go away completely in the industry. And I think the best thing to do is kind of rationalize it, understand it, and realize that if somebody is sexist, racist, or they're ageist, or any of those different things, they self-select. Awesome. great. You don't want to party with those people anyway, right? So if you're getting to the point where you're like me or you have 30 years of experience, I'm at 25-ish years of experience. And I absolutely recognize because I talk to companies and they'll say things like, ooh, this dude's like 55 years old. Is he going to be a go-getter, right? They worry about that. And that's not right. That's not good. That's not a wonderful thing, but analyze it, rationalize it as something that exists, and then try to find a way to work around it. So if we're looking at like the ageism thing, most of the time what people are worried about whenever you get to the level of experience like we have and more, they're worried that you're completely set in your ways and you don't want to change, right? So to address that issue and concern, make sure that you're learning new techniques, new things like Kubernetes, Ansible, working with Docker and all these cutting edge technologies, maybe Rust, I don't know, something a young hipster with fancy facial hair would recognize. Make sure you understand these things and that's in your resume so it shows that you're somebody that's not just locked in the way you did it years ago, that you're embracing new things. And like I said, these things exist, they suck. I'm acknowledging that they suck, and I think it's important that we acknowledge that they suck. But the reality is sometimes you just work around these things. And the further reality is it's great. Like if somebody doesn't want to work, like I'll give you an example, me, right? This is kind of who I am now. I'm not corporate. I'm not somebody that's going to be showing up in a suit with slicked back hair, lots of, jewelry and rings and trying to sell you on BHIS. I show up in t-shirts and jeans. That's kind of who I am. And we have customers that absolutely are biased against me. Like I had one customer, their IT manager told me this. I had a beard at the time, and their CEO had something against dudes with beards. He was just like, yeah, people with beards are just generally lazy. Okay, I can get mad about that, but I was actually relieved because F them. That's why. It makes it so much easier for me when those people in those relationships self-select out so I can focus on partying with people that want to do good things. That was a long answer. Sorry about that. Are there any plans to the new offensive curriculum in ACE-T at some point? It will be, Rooster, but it's going to be a dynamic. You'll start with ACE-T core, and then as you progress out from there, it'll be part of the categories that you're learning in that spider graph as well. Malware Jake, he works with Alyssa Torres, his wife, and he's got a class that he's releasing on AI hacking. So that is going to be coming here in just a little bit as well. All right. Oh my gosh, you guys got really into it. Can you tell us more about the Antisyphon BHIS road trip plan? Let's go back to COVID. I think that's a good place to start. When COVID hit, there was actually a drop off in pen testing contracts. And you really have two separate ways that you can deal with an economic downturn. We started in 2007, 2008 during the housing crisis and the Great Recession. And then in COVID, we were confronted again with what do we do? Do we go into a defensive crouch position? Do we start laying off people, get back, get lean, and try to deal with it? Or do we say, F it, we're going to get out, we're going to push, we're going to do as much as we can for free with our hands out to give? Because I have a fundamental belief that companies that have their hands out to give are better companies than the ones that have their hands out to constantly take. So we started the pay what you can training with Antisyphon, and it skyrocketed. Like COVID years were some of the biggest growth years we ever had. So we're looking at trying to expand and do more training. And with that in mind, we are looking at like, well, we want to do a training class in DC. So if I show up and I do a training class in DC and I charge like $500,000 for a training class, that normally would work just fine. But when we're looking at the situation with the kind of what's going on with the federal government, that's not going to be something that's going to be well received. Like we're not going to do well. So what we're going to do instead is go on that road trip where we're going to start doing pay what you can. Chris and myself are the two people that are on deck. Maybe Kevin Johnson will get him as well. It depends on the spaces that we can find. We're going to do that pay what you can training, but live. And we're going to try to get some vendors to sponsor it to help offset the costs, but we're going to try to go to different spaces around the United States and globally to bring this pay what you can training to as many people out there as well. All right. Oops. Looks like Discord went way far back on those. Yeah, beards. Yeah, beards. I don't know why. I don't know why. I thought that was one of the strangest things ever. Saying like, yeah, we don't like it. Okay. Sorry, I'm trying to get caught up. Like I said, if you're talking with each other, that's fine. But if you have a question for me at StrandJS, speaking of isms and assist, do you have any thoughts on the newest conversation that DEI is a bad thing and destroying anything and anyone that practices it? That's kind of getting into politics, but oh, um, okay. So I'm going to put it this way. I think that whenever you start trying to cut things like DEI, I think that we have an idea in our head, a straw person of what that is, right? And hiring vets is part of a DEI initiative. For Harvard and Yale and Stanford and MIT, they bring in students from the Midwest, from places like Wyoming, South Dakota, Colorado, Montana. They specifically bring in a disproportionate number of students from those states. That is also DEI. And if we're looking at diversity, I think a lot of people like to crap on the idea. It's like, well, why do we need diversity? And I think if you look at a lot of our technologies and you look at how the technology is advanced, and you look at just using a couple of examples, the contribution of women to the early days of computing and computer science. I'll give you an example. So if you look at punch card systems, computer system and programs and operating systems used to be ran on punch cards, right? And everybody's seen these punch cards. Everyone knows these punch cards. But what a lot of people don't know is when they were writing programs, there were certain sets of punch cards that would be reading a file. There would be certain sets of punch cards that would be writing a file. There would be certain sets of punch cards that would be doing mathematical algorithms. So a lot of the punch card creation was done by women in that time because they would sit down at a typewriter and type this stuff in. And they're like, sitting at a typewriter, that's women's work. So they would basically say, oh, you're going to do the punch cards. You're going to do this. We're going to give that to the ladies. And then we're going to sit around, smoke cigarettes in white lab coats and drink scotch. I don't know. I wasn't alive in the 50s and 60s. All right. I'm just guessing based on the pictures because the dudes had cigarettes and scotch in those pictures. But if you can actually see color versions of a lot of those pictures, a lot of the women that were doing those early computing things, they would color code their cards. So they would redo the exact same things again and again and again. And they started using punch card reuse for reading a file, for writing a file, for doing these different things. And in a lot of ways, they were kind of the beginning of the operating system libraries that we use today. Now, other people developed operating systems and the concepts of libraries, but truly it was them, you know. Look at Hidden Figures, great movie, right? If you're looking at, oh God, what's her name from the NSA? Rear Admiral Grace Hopper, and her earlier contributions. If you look at our mathematics, we use Arabic mathematics, right? So I am truly a believer in the concept of diversity of thought and bringing this together because different cultures, and even within the United States, right? Different cultures have different ways of dealing with things. And when you apply that to something like the FBI, you desperately need to have diversity because you're working across a diverse space. So I think that that's all I'm going to say about that. I've probably already pissed off people at that point as well.
No, I think that you worded that perfectly, John. I'm a little
Thank you.
biased though.
I am a little bit. So. What's a good way to list these trainings on your resume? Just put it right up in trainings and certifications. Just say SOC core skills with John Strand, intro to security with John Strand as well. I hope you consider Montana State for your live classes on the road. Guy, I'm at MSU all the time. My kids go to school there. You got to reach out to me and we can get together and we can go downtown. We go to Dave's Sushi. Does that sound like fun? I love Dave's Sushi. I know that they had a problem with people dying due to mushrooms, but I think they got that well under control now as well. So there we go. Using Hash Suite for password cracking took 3 hours to crack a 27 character password rock you word list. It's taking days and still cracking up to 27 characters. Now, really, you don't know how long it's going to take EF5. You're not going to see how long it's going to take because what it's doing is it's taking that RockU database and now it's starting to do a combination of words in different orders and then doing character substitutions within those words. So it's almost impossible to come up on what it's going to take to completely exhaust all possible key space. Because what it's going to do after it's done the word mangling that it's doing, because that's called, it's then going to go into a brute force mode, and that brute force mode will go until the heat death of the universe as well. All right. All right. Okay. Do not skip that invitation. What do we got? You recommend all the pay what you can courses? No, if you take my two main courses, you're ready for ACE-T. If you've done the SOC core skills and you've done this class, you're ready for ACE-T and get into it, get working.
And if you didn't catch it live, the SOC core skills, it's on our YouTube channel if you need to go
Sure it
back
is.
and do that.
It's available to you. So check
Yep.
it out. All right, everybody. Let's go ahead and let's wrap it up. I want to say thank you so much. And the number of road trips, Chad, that we're going to be doing. Honestly, I have absolutely no idea whatsoever. We're trying to work that out, and a lot of it has to do with universities and how many universities we can find. So we're going to get out there as much as we can. We're bringing the party to you guys. So thanks so much, and I will see you tomorrow.
All right. Have a good evening, everybody.
Later.
Bye. Megan, you can go ahead and kill it with fire.